Hi guys. So one of the students have asked me about these four problems from our section 4.3, which is about logarithmic functions. Anyway, to kind of save some time, I went ahead and characterized the two, well, she asked for four questions, but three of them are on one type of problem, and the one of them, of course, is the other type. So what I did, I kind of separate them. So number 77, 81, and 82 are going to be worked out. Well, at least we have to do one thing for those set instruction, and then for number 84 and beyond, after that one also we have to follow another instruction, okay? So the reason why I put the arrows in this, under these two separate categories, and also direction is different, because to do problem 77, 81, and 82, you would have to apply three properties, which are known as the power property, quotient property. By the way, the name power property because this applies to log of a product, it's called. Sorry about that. I apologize. I meant to say product property because you have a product here. So this is called product property. Here you have a quotient. So we call this one quotient property of log. And this is, of course, you have a power involved. So we call this the power property of log. And so anyway, so what they will ask you to do in these three problems, the instruction is a bit ambiguous because I know that in the book they say to rewrite these logarithmic expressions, except they don't exactly tell you what they mean by rewrite. So, but what I'm going to tell you right now is that what they want you to do in the problems, these three, and also all the ones in your textbook, from 71 all the way to problem 82, okay? They ask you to do the same thing. They want you to basically apply these three properties of log to remove all products, remove all quotients, and remove all power, okay? So some books, they call this idea expanding, because you take in one log and you write it as either sum of two log or difference of two log or even sometime more than two logs. So they call this idea expanding. Now, for problem 84, this is opposite. This time, what they give you is 2 or 3 or 4 logs, and they want you to actually, this is called condensed. So they want you to condense it to one exactly what they call single log. So this time you go on opposite. And you want to go from 2 or 3 or 4 logs into single log. Where here, for these three problems, you have one single log, and you write it as the sum or difference of 2 or 3 or more logs. Anyways, but you apply the same three properties, except for these three, you have to apply it going from left to right, which means when you have one log, you put it as 2 logs. Where in 84, you're going to apply the same property going from right to left. In other words, if you see a sum of 2 log, you can change it to log of their product, which means it condenses from 2 log to 1 log. Anyway, so this is the idea how you're going to proceed with these two different categories. But I'm going to go ahead and pause for a minute so that we can make, well, this, as I mentioned before, these three properties are written in your textbook on page 447. On page 447 on the, I apologize. I'm sorry, on page 441. Sorry about that. On page 441, they have these properties in a green box in your book. So you can also look at them there. So, because I'm going to have to remove them to be able to show you how to do problem 77 using these three properties. Now, sometimes you may not have to use all three of them. For example, if you don't have a quotient, of course, you don't have to worry about this property. If you don't have a product, for example, you don't have to worry about that. But sometimes you will have to use all the three properties, because in your expression, you will have products, you will have quotients, and you'll have powers. So you will end up using all of them. So we'll write down number 77 in a minute. And then we can see which properties we're going to have to use to be able to basically expand this one log into 2 or 3 or more logs. So bottom line, before I erase them, this is basically what it tells you. Log of the product, you can write as sum of their logs. In other words, log of the first factor plus log of the second factor. So in other words, log of the product, sum of their logs. Log of the quotient, difference of their logs, meaning that log of the top minus log of the denominator. And then, of course, log of x to the power times the log. And that's how you can eliminate the power. Okay, so these are known as the product property, quotient property, and the power property of logarithms. I'm going to erase them right now, and we work on 77 to show you how we can use some of these properties. So let me copy problem number 77. And we have log base 2 of the square root on the numerator. We have 5r cubed, and the denominator is z to the 5th power. Okay, so here's our one log or single log expression, and we want to basically expand it. And that's what they mean by the instruction when they say rewrite. So, and now what did I say that exactly means? Is of course, if you see any quotient, like for example, we have a quotient in this expression, we have to remove the quotient. Upstairs, you have 5r cubed, which mathematically means 5 times r cubed. As you know, there is nothing between two things in math, means multiplication. Since you can't have any product left, you have to also remove that product. You can see also there's some exponents involved, so you will also have to use the power property to remove the exponents. So actually, this is a good example because this one will show you how to use all the 3 properties that I just mentioned to be able to achieve our goal, okay? But the very first thing we're actually going to have to do is to basically rewrite the square root, because none of the properties that you have that we talked about applies to a square root. So we have to, well, by the way, this is not just a square root. If you have a cube root, 4th root, 5th root, you always have to rewrite them as an exponent, because you can remove exponents, but you can't remove radicals, right? So of course, by now all of you know that a square root of anything is the same thing raised to 1/2, right? So basically, this is how you can convert this square root into power. And that's your first step. So you're going to write that as log base 2 of 5r cubed over z to the 5th, all raised to 1/2. So your square root basically becomes power 1/2. So now the first thing we're going to do, we're going to remove the very first exponent, which of course you still have log of something to a power. So we can also apply the power property. Not only are we going to apply the power property in here within these expressions, but we can actually even remove it from the whole thing, the outside of the whole thing, because this is what you have is what? Log base 2 of something to a power. And the rule doesn't care what you have in here, as long as you have something to a power. The rule says you can bring the power and put it in front. So therefore, by that so-called power property, we can rewrite that as 1/2 log base A of 5r cubed over z to the 5th. Okay, so that was our first step to remove. Well, first step was to rewrite the square root as power 1/2. That's what we did. And that's a must, unless you change this radical. Again, as I said, not just a square root, any cube root, 4th root, 5th root, you must always write them as an exponent. And once you change them to exponent, and of course, you remember that rule, the fact that you can go from a square root to exponent. Remember that we talked about that many days ago, which is the one that says a to the m over n is the nth root of a to the m. If you remember, we had that rule. So that's how we can convert from radical to exponent. Anyway, so this is what we have so far. Now, of course, this is where the fun starts. So the next thing will be to remove the quotient. We're going to apply the quotient property. And then after that, we're going to remove the product and then those powers, okay? So, but since I don't have enough room, I'm going to pause for a minute and make sure you make a note of this. I'm sure you can always rewind the tape and look at it again. And then I'm going to go back up here and try to proceed from here to the next step. Okay, so this is where we are. So now from here, we're going to proceed up here. So the next thing we're going to do, I'm going to go ahead and leave the 1/2 in front for now. I'm going to take this log of the quotient. Since I'm going to have 2 logs now coming in, I'm going to put this stuff in bracket because otherwise I may forget to distribute the 1/2 by all the terms, right? Because now I'm going to go from 1 log to 2 log based on the quotient property. So what does the quotient property says? It says log of the quotient is log of the top, whatever the top is, minus log of your bottom, your denominator. So in this case, that will be log base, should be base 2, not A. So we have log base 2 of the numerator, which is 5r cubed. And then, I try to be careful with the space and I have to keep, okay. Minus, as you remember, the quotient always turns into difference between the logs, log of the top, and then minus log of the denominator. Log base 2 of z to the 5th. Okay, so now the next thing is we're going to have to go back to our first log since we can't have any products left. As you remember, I told you a minute ago, 5r cubed means, of course, 5 times r cubed. So we're going to go ahead and remove that product by the product property that says, and let me remove this. That says this is the same thing as 1/2. So as we said, log of the product is sum of the logs. Log of the first factor plus log of the second. So this time will be log base 2 of 5 plus log, excuse the writing here, this marker on my knees. So log base 2 of r cubed. And you still have the last term, minus log base 2 of z to the 5th. So looking pretty good. There is one more issue remaining. As you remember, we said we can't have exponents or power either left. So we're going to once again, just like we did at the very beginning, by bringing the 1/2 to the front, we're going to remove these 2 powers inside. So this will turn into 3 times log base 2 of r. That will become minus 5 times log base 2 of z, okay? So let me write the final conclusion up here. And then I'll pause for a minute, make sure everybody is okay. Even though I can't hear you, I hope my soul can feel you. That's all I can hope for. I'm sure we can handle it. Okay, so finally, this is the final expression. So now you have 1/2 log base 2 of 5 plus log base 2 of. So here, of course, we need since we're going to go ahead and bring the power down, let me go ahead and apply that already. So that 3 becomes to the front, becomes your coefficient, becomes 3 log base 2 of r. Also, the 5 comes to the front, becomes minus 5 log base 2 of z. Okay? So now some textbook, they will leave the answer like that because we did pretty much accomplish all the goals. We got rid of all the products in the expression. That's how we got the sum coming in. We got rid of the quotient. That's where difference comes in. And of course, we got rid of the powers. That's how we got those coefficients to show up in front. Now, some books may actually distribute the 1/2 by all the terms for their final answer. So I'll go ahead and do that one also just in case. So both are correct. It just depends whether they want to distribute the 1/2 or whether they want to leave it in front, okay? So, but if you do distribute, so this could be definitely a final answer in some cases. Or you could also write it as after you distribute, so that becomes 1/2 log base 2 of 5. Then, of course, 1/2 times 3 in front, which makes that into 3/2 log base 2 of r. And then, of course, 1/2 times 5 becomes 5 minus 5/2 log base 2 of z. Oops, we don't need the bracket anymore because we already distributed. Okay, so sometime this could be the last conclusion or last final answer. Some books may leave it like that, but they both are correct. They are the same thing. You just do different representation. Okay, so this was problem number 77. So it looks like the problem 81 and 82 are very, very similar. I'm sure they may even use the same ideas, of course. And well, all the ideas are going to be the same, as I said, in all these problems. These three among the group that I mentioned earlier. Now, of course, you may have to use different, deal with different numbers or letters or whatever, but the same properties is product property, quotient property, and the power property is usually what you need to use. Okay, so I'm going to see if I can maybe choose one of the other ones, 81 or 82. Work that one too, just to give you one more example, and then we'll do also 84, which will be the other category where, oh, by the way, before I go to that next example, so here's what's going to happen. Like in 84, of course, it's not going to be this ugly, basically, or this many things involved. But in 84, they will give you, I mean, in this 84 and many, many more like them, they will give you something like this. You have like 2 or 3 logs. They want you to take this and make it into one log. So this time you're doing the opposite of what we just did here in 77. They give you the ending, they want the beginning. So you just have to go backward. But remember, you're going to use the same properties that we just used going this way, except now you're going to apply them going this way. This time when you see a sum, you're going to make that into what? Remember, sum becomes a product. So you just went from 2 log into 1 log. And then you see difference of 2 log, that becomes log of just 1 quotient. So there it is. There's your single log, okay? So it's going to be going this way. But before we worry about that one, let me see if I can do one more of these, and then we'll also work on 84. So let me do actually 82. I mean, 81 and 82 are pretty much very similar, but because they both have radicals and all that good stuff. But 82 seems to be a little bit more interesting. So let me do 82. I'm sure if you understand 82, 81 should be pretty much the same. Okay. So here's our expression in 82. We have log base 4 of, now on the top, we have cube root of a times 4th root of b all over square root of c times cube root of d squared. Okay, so this is definitely a little bit more interesting than the last one, number 77, but it is going to be the same thing. So right off the bat, I can see that in this problem, we are going to also use the same 3 properties, all of them, because you can see there are products involved on top and the bottom. So we have to remove the product. By product property, we have a quotient, of course, ultimately has to be removed by quotient property. And of course, as I mentioned in the last example in number 77, those radicals, they all have to be written as exponents. Remember, we can't do anything with radicals, so we have to convert them to exponent. And so, and once you do that, of course, you will also have power, so you also remove the power by power property. So anyway, so we will going to be able to use all the same 3 properties, okay? So let me first, don't forget, the first step is to rewrite all these radicals. Again, don't forget where that come from. That, of course, come from the rule. I'm going to actually write it. Let me see if you can see that, probably a little bit too high. But this is the rule that, as I said, but remember the rule a to the m over n is the same thing as nth root of a to the m, okay? So all these radicals can be written as exponents by using that property. So I'm not going to bore you with that property. I'm sure you have it in your notes somewhere. But let me just use it and rewrite this as, so this becomes log base 4. Now cube root, as you know, becomes a raised to the 1/3 times fourth root becomes b raised to the 1/4 all over. A square root, of course, as you know, is c to the 1/2. By the way, if you notice the pattern, as you can see, all your denominators, of course, the numerator is always going to be 1, and well, not in every case, but in these first cases, because you don't have any exponent under there. And then your denominator, notice that what is always your root, which root you're taking. So if you're taking a square root, which is 2, that bottom denominator is 2. If you're doing cube root, the bottom, as you can see, is 3. If it's a fourth root, so but they all come from that rule that I mentioned. Okay, anyway, and then this is, of course, based on that same rule, this becomes d raised to the 2/3. So this time the top is not 1 because you do have an exponent under the cube root also. Okay, so now I'm pretty sure you can finish it from here, because this is pretty much from here is going to be similar to the number 77. But I'm going to go ahead and apply one more step, and then we'll finish it together. But I'm going to take one more step. So first I'm going to remove the quotient by the quotient property, which you remember says log of the quotient is log of the numerator minus log of the denominator. So let me just apply that, and then we go move it upstairs. So that's log base 4 of a to the 1/3 times b to the 1/4, then minus log base 4 of c to the 1/2 times d to the 2/3. I know that's getting a little bit too low, so let me move my... Okay. Sometimes people put parentheses around this, sometimes they don't. Parentheses are here for just looks. They're not necessary, but if that helps you to see it better, you can also put them there, okay? So we already achieved one goal. We did remove the quotient by the quotient property. So we end up now with 2 log. Now we got to go to each of these logs. Now we have product in both cases. And of course, we have to apply the product in both cases. Now the only thing I'm going to concern you, or at least make you pay attention to is, and this is sometimes why some students don't have the same answer as the back of the book for this problem, because the fact that, of course, this is even one, but I think number 81 has the same idea, because they forget that since you have a minus in front here, right? Once you apply the product property, as you know, you're going to remove 1 log and put 2 log, which becomes sum of 2 logs, right? But then that negative has to be distributed by both your logs, not just the first log. So some people forget to distribute the negative, and that's how they get the final last term wrong as far as the sign. But I'll show it to you how to do it correctly, so hopefully that won't happen to you, okay? All right, so I'll give you a second to make a note of this. I'm going to go upstairs and take this and try to remove the product next. Okay, so from here, we're going to have, so first I'm going to remove this product. And don't forget that the product property says log of this product becomes sum of their logs. In other words, log of the first factor plus log of the second factor. So it's going to look like this. Log base 4 of a to the 1/3 plus log base 4 of b to the 1/4. So there is your product property applied to this first logarithmic term. Now to this one, same thing, except don't forget that minus. See here, you don't need a parenthesis because there is nothing in front. The sign in front is plus. But here you have a minus, which means that minus has to distribute it by both terms once you replace this 1 log with 2. But let me write it correctly. So you do put the minus, except I recommend you open a parenthesis. And then after you apply the product property, make sure you put both of those log inside the parentheses. So that becomes log base 4 of c to the 1/2 plus log base 4 of d to the 2/3. This is sorry guys, okay, so now you see why we need the 2 term in parentheses, because you see that negative, a minute ago you didn't need a parenthesis here because there's only 1 term. But once you replace that 1 log with 2 logs, that negative still remains in front. So now it has to be distributed by both of your logs. In other words, that negative is going to change both signs, not just the first term, okay? So what I'm going to do, I'm going to try to do both next two steps in one step. I'm sure you can handle that. So the last step is to remove all these powers by power property. So they're all going to come in front. They're going to become your coefficient. But also as I do that, when I bring the power down, I'm going to also apply the negative. So that way the last two terms will be written, of course, as we distribute also. Okay, so this should be your final answer. So the power 1/3, again, by power property comes to the front. So that becomes 1/3 log base 4 of A. Plus, again, that 1/4 by power property comes to the front, becomes 1/4 log base 4 of B. And then as I bring the power 1/2 down, I'm going to also apply the negative. So that should look like negative 1/2 log base 4 of C. And finally, as you distribute the negative by the second term, that also becomes minus, not plus. And that's why you want that parenthesis to be, not that you forget to, so hope that you don't forget to distribute the negative by the second log. And anyway, and that 2/3 again come down by power property. And that should be your final answer, log base 4 of D. Let me box it, make sure you can read it. Looks like you can see it. So I'll pause for a second. And by the way, as you look at these videos, if you do have any further questions about any videos, I'm sure, I mean, you may see something here that I may even, well, not even, I do make a lot of mistakes sometimes. But anyway, so if you see a mistake or if you basically don't understand something that I explained here, because the quality of the video or my lecture, please ask me again, message me through Blackboard so I can hopefully respond and hopefully clarify it for you, okay? All right, guys, so let me go ahead and work. So I let you look at the other one. I think I did for you 82, which was the last one. So you also can now, you try yourself do 81 because it's a little bit even less involved than 82. So hopefully you can handle that, okay? Let me also do one more because I think I'm gonna need a break here in a minute. So let me do one more for you, 84. And so this time, don't forget I mentioned that this is gonna be opposite phenomena. So this time they're gonna give you 2 or 3 or 4 logs. They want you to change them to a single log. So we're going to, again, apply the same 3 properties going backward. So I'm not gonna write the properties again. I think you have them by now. So I'm just going to go ahead and write the problem 84 and show you how we're going to go backward, which some books they call that idea condensing instead of the last group, which are usually called expanding. But either way, let's see what 84 is going to work out by. So I'm just going to go ahead and move it over here. This is number 84. Let me write it over here, number 84. Okay, so let me write the expression, then I'll see if we can agree with how we're going to do it. So you have log base B of K plus log base B of M minus log base B of A. Okay. Now, let me just read the instruction from the book. This is pretty clear. I know the last group was a little bit ambiguous, but this one I think is more clear. It says to write each expression as a single logarithm with coefficient 1. Okay, so he wants us to write this expression as a single log, which means only one log, not 3 logs like here, with coefficient 1. Coefficient, remember, being the number in front. So he wants to make sure at the very end, not maybe here, but at the very end, the last log, the single log, has the number 1 in front, okay? Now, this time, I don't think we have any problem with that because there are no numbers except 1 in front, but sometimes you have to worry about that, okay? But for now, we're going to see how can we go from this 1, 2, 3 logs to single log. So as I said, I told you a minute ago, we're going to apply the same property, the product, the quotient, and the power to try to go back from, in this case, 3 log to 1 log. So this time, instead of going from product to sum of 2 log, when you see a sum, you're going to make it condense it to log of their product. So this just becomes log of k times m, right? It's kind of going backward from right to left on those 3 properties. When you see a minus, you're going to make it into a quotient. Remember, difference of the logs is log of the first over log of the second one, okay? Now, the only thing you have to be careful, of course, is since you do have 3 log, I do want to make one very, very important recommendation, because if you don't follow this recommendation, you may not always get the answer correctly, okay? So whenever you have more than 2 logs, like here you have 1, 2, 3, you could have 1, 2, 3, 4, or 1, 2, 3, 4, 5, or whatever. But as long as you have more than 2 logs, so in other words, 3 log or more, here's my recommendation. First of all, to condense these 3 logs into 1 log, always try to go from left to right. Don't try to condense them from right to left. Always go from left to right. And number 2, make sure you just combine or condense 2 logs at a time. In other words, don't look at all 3. Just take the first 2, condense them to 1 log, and then bring the next one down, and then condense those 2 to 1 log. In other words, take 2 logs at a time, combine them to 1 log, and also go from left to right. So if you follow those 2 ideas, you will always get the correct answer, okay? So the first question is, how do I go from sum of 2 logs? So for a minute, I'm going to ignore the term is there. I'm just look at the first 2 logs. And of course, the sum, remember, becomes log of their product. So that becomes log base b of k times m, or just km. And that again comes from the product property. Remember, log of the product, sum of the log. Except now you go backward. Sum of the log, log of their product. Now you bring the last log down. That's what I mean by 2 logs at a time, left to right. Always remember that. So now you have difference of 2 log. Well, what property lets you go from difference of 2 logs to 1 log? Of course, that's the one we call the quotient property. And it says difference of 2 log can be written as log of the quotient. In other words, log of the first expression, which is km, divided by the second expression, which is just simply little a. And now again, sometimes people put parentheses, sometimes they don't. In this case, it's not necessary, but it may look good. So, and that's it. There is your single log. Of course, coefficient is 1. Now, in this case, it's 1 because it was always 1 in all the logs. But sometimes you do have to make it 1 yourself. But for now, at least, we have our single log with coefficient of 1. I'm just going to box that because this is right here. Should be and is your final answer for 84. So, of course, the problem 84 was not, the terms were not that involved. They don't get too involved, but obviously there's some more, I'm sure, later homework in the same group may be more involved. But with this, of course, maybe this can help you to also approach or attack the other ones. Okay, so I'm going to go ahead and post this on the YouTube. So I hope this helps. If you have any further questions, let me know. Thank you. Bye.